Alright, so I spent about 4 hours writing all this out for my third exam in micro on Tuesday, which, not counting today, is 3 days away. One of the things that I wanted to discuss more about is in regards to antibodies and, most importantly, serum immunoglobulins or serum antibodies, because the first time that I took micro, I didn't do too hot with this section. So, going to refer to antibodies, antigens, things like that. So an abbreviation for an antibody is AB. It is also referred to as IG or serum immunoglobulins. Antigens, the abbreviation is AG, and is referred to as an immunogen or an allergen, but I'm just going to say antigen. Now, in regards to a antibody-antigen reaction, this is where the antibody attaches to the antigen at specific sites around the outside of the cell, referred to as epitopes. Epitope for singular, epitopes for plural. So we have two types of acquired immunity. We can get them actively or passively. Active is where the body makes its own antibodies. One of the options of that is natural active, such as being around someone who's sick, someone who has rhinovirus. Our body would make natural antibodies, so we would not get that infection also. Moving on, we have artificial active, and this is acquired from a vaccine. Passive is where we're going to get these antibodies from another human or an animal. We have natural passive, where the antibodies are given from mom to an infant. And then artificial passive is in regards to an antibody via injection, a short-term, short-lived, if you will, injection. Specifically referring to the ROGAM injection. This is in regards to if mom and the father have two different blood types. One's positive, the other's negative. That is what the ROGAM injection is for, mainly for the fetus in vitro to not be attacked by the mom's immune system. Out of those four options, natural active lasts the longest. Moving on to the serum antibodies, we're going to start off first with IgM because IgM is the first to arrive at the site of an infection. This molecular weight is the highest of all of them at 970,000 Daltons, and IgM is also a pentamer. It is the only pentamer. Everything else essentially is a monomer. IgM also does not cross the fetal placental membrane. So mom keeps this within her, baby does not get any of this. Next, we're going to go down to IgA with a molecular weight in blood as a monomer of 70,000 Daltons, which is the lowest weight of all of these serum antibodies, followed by 400,000 Daltons when the IgA is a dimer in secretions. So IgA has two different molecular weights depending on what it's being used for. IgA is also found in mucus, saliva, tears, colostrum, and blood. This is the first immunoglobulin that the body produces, and if a bacteria produces IgA, antibiotics are futile. The bacteria will become resistant if they form IgA. Next on our list, IgE. This works with allergic reactions, also referred to as hypersensitivities. The molecular weight of IgE is 190,000 Daltons. It also carries the allergen antibody, and IgE is the largest yet least abundant of all of the serum antibodies. IgE is a monomer. Moving on to IgG, the most abundant of all of the immunoglobulins, we have a molecular weight of 150,000 Daltons. IgG protects against microbes. It triggers the complement system in regards to infections, treating and preventing infections. And IgG crosses the fetal placental membrane. So baby gets mom's IgG. IgG, like IgE, is a monomer. And last but not least, we have IgD with a molecular weight of 175,000 Daltons. IgD, like IgE and IgG, is a monomer, and it is the second least abundant. IgG also has internal markers on B lymphocytes. So, key points from this: IgM is the first to arrive, does not cross the fetal placental membrane. IgA has 2 molecular weights. However, when it is a monomer in blood, it has the lowest molecular weight at 70,000 Daltons. IgE is the largest and least abundant. It works with allergic reactions. IgG is the most abundant, and it crosses the fetal placental membrane. And IgD has internal markers on B lymphocytes. And that is that on our serum immunoglobulins.